Okay, so here in this video, I'm going to go over the solutions to homework number 12, which is solving nonlinear inequalities. This works better. Okay. All right, so the first part, we're presented with a function f and its graph, and we're to find all values of x, not y, for which the function in part 1 or in number 1 is greater than 0. So what this means graphically is we want to see for which values of x is the function, its graph, above the x-axis. So we often don't realize that when we're above the x-axis, these are where the y's are positive or greater than 0. And when we're below the x-axis, that's where the y's are negative. And when we're on the x-axis, that's where the y's equal 0. So how do I read this? I'm looking for the x's for when the y's are above the x-axis. So if I trace these x's, these y's take me below. So all these y's down here are negative. If I come over to here past -2, all of these y's are all positive. So I'm just going to put a big positive sign there. And then now when I come over here between 1 and 2, all these x's here have negative y's. So this would be negative, and then now all these are positive. So for which x's is the function positive or its graph is above the x-axis? So that would be from, let's see if I can have some room here, -2 to 1, and then from 2 to infinity. Remember, you cannot include the 2, the -2, or the 1, because that's where it equals 0. So everything's a parenthesis. If it just has a greater than or less than, everything is a parenthesis. Now I want the x's for which the function is less than or equal to 0. So when is the graph below the x-axis? That's from -infinity to -2 bracket, because I'm including it now, and then also from 1 to 2. This is where from when x is 1 to when x is 2, the graph sits below the x-axis. And because it's the equal to part, we have to include that with the bracket. And then for which values of x is the function equal to 0, then that means where it hits the x-axis, and that is like what we said at -2, 1, and 2. And now I want to solve these inequalities by using what we call as the candidate test or the number line test. And we want to write our answer in the interval notation. Whenever you solve a nonlinear inequality, you want to follow these steps. Set it to 0, whether it's greater than or less than, just set it to 0. You want to factor the expression completely. And then you want to do your number line test or your candidate test on your critical points. So it's like kind of number line test. And then step 4, you write your solutions or your answers, if you will. So in this very first problem here, number 4, it is already set to 0 and it is already factored. So the critical points come from setting each of these factors equal to 0. And that's happening at x equals 1 and x equals -2. So now in my third step, I'm going to build a number line, -1 and 2, kind of running out of room here. And because there's no equal to on this, everything will be an open circle. I'll pick any number I want to the left of -1, like -10, and I'll put that in for x. So -10 minus 1 is a -11 or a negative, and a -10 plus 2 is a -8. But that negative times that negative produces a positive, which means the graph of that function is above the x-axis at that point, from -infinity to -1. So I'll just indicate that that whole area there, that whole region is positive. And then because we talked about in class that because these multiplicities are odd at 1 and -2, the number line will alternate from positive to negative and then negative to positive. But remember, that's not always the case if there was an even multiplicity. And now finally, I'll write my answer in step 4. Where is the number line negative will indicate where it's less than 0. So it's less than 0 where the number line is negative, and that's from -1 to 2. And again, everything's a parenthesis because there's no equal to. All right, number 5, what do we got? Got this polynomial. It's already set to 0, but I do have to factor this. So I'm going to factor this into x minus 3 and x plus 2 is greater than or equal to 0. Next, I'm going to do the number line test, and it's performed on the critical points. That's going to be 3, and that critical point is -2. Because of the equal to, both of these will be a closed circle. All right, I'll pick a number to the left of -2. I can pick -10 again. And where I put that is sometimes is where the confusion is. I put -10 in for x. And -10 minus 3 is -13. And -10 plus 2 is a -8. But I don't really need to know that it's a -8 even, just know that it's negative. And a negative times a negative is a positive. So the rest of the signs are pretty easy to figure out. Because these multiplicities are odd, we know that its graph is going to cross the x-axis at those zeros, which we talked about in the prior lesson. That when these multiplicities are odd, the graph of the function will cross the x-axis at those zeros. And when you cross the x-axis, your y's are alternating signs. So it will go from positive to negative, back to positive. Now, where is my number line positive is the answer where it's greater than or equal to 0. And that's going to be from -infinity, bracket to -2, and then bracket from 3 to infinity. And we include them now because of the equal to part. All right, and number 6, represented with this inequality where it's already set to 0 and it's already factored, so that's huge. We don't have to do any factoring, but we do have this even multiplicity to worry about. So my critical points will be -1, 3, and -4. And I'm going to do a number line test. We call that the candidate test or a number line test. Just make sure you put them in the right order, otherwise I'll present a problem. And because there's no equal to part, I'm just going to have everything be an open circle. What number is to the left of -4 is -10. I'm going to sub that in for x. So -10 plus 1 is a -9, I know. Squared is a positive. Kind of running out of room here, so that's a positive. -10 minus 3 is -13, so that's a negative. And -10 plus 4 is a -6. So a negative times a negative is a positive times a positive is a positive. So that very first interval right here, all the y's are positive. Now the rest is easy to figure out. The signs will alternate at -4 because -4 came from an odd multiplicity. So it's going to go from positive to negative. But the -1, this critical point here, came from the even multiplicity. So it's just going to bounce off the x-axis and still stay negative. Because the 3 came from an odd multiplicity, it's going to alternate signs, and it's going to go to a positive. So where's my number line greater than 0? Where's the function greater than 0 is where the number line is positive. So where's that going to be from? Kind of running out of room here. I don't really like doing homework on top of these, but pays instead of rewriting them all over again. So it's going to be from -infinity to -4, and then a union with 3 to infinity. That for everything's positive. And again, what that means graphically is that the graph is above the x-axis here. It sits below the x-axis in between here, and then it's above the x-axis again. In number 7, what have we got? It's already set to 0, and it's already factored. So my critical points are when x equals 0, x equals 4, and x equals -3. I'm going to do a number line test on all of those. Just make sure I put them in the right order. And again, because there's no equal to part, everything will be an open circle. So sometimes to help you keep track of these things, when you see this even power, you've got to have the same sign on both sides of this critical point 4, because remember, we said that it bounces off the x-axis there. And when it has that odd multiplicity, it's going to pass through the x-axis where the signs have to alternate. So another number to the left of this is -10. It's pretty easy to compute. So I'm putting -10 in for x, and that's a negative. Anything squared is a positive, so don't even worry about that. And -10 plus 3 is a -7. And a negative times this negative is a positive. And that's what I really want to record. So from there, I know the rest. Okay, so if I do the positive at -3, it's got to alternate signs to negative because the -3 came from the the odd multiplicity. At 0, it's going to alternate back to positive because 0 came from this odd multiplicity. But 4 came from this even multiplicity, where it's going to stay the same sign as the other side because it's going to bounce off the x-axis there. So whereas my number line is positive is where the inequality is greater than 0. And that's happening here, here, and here. So my final answer is -infinity to -3 in union with 0 to 4 in a union with 4 to infinity. If you don't put the union with, that's okay. And then number 8, we already have it set to 0, but we don't have it factored. So you always start with the GCF, but I can factor that further into x times x minus 1 and x plus 1 less 3 equals 0. I got 3 critical points, x equals 0, x equals 1, and x equals -1. And putting those in numerical order, because of this equal to part, all these circles are closed, which means their solutions will have a bracket when they're included. So I got all these odd multiplicities. So that means this entire number line, the signs will alternate because the graph is crossing the x-axis at each of those zeros. So if I pick, say, -10, I'll get a -10 times a -11 times a -9, and an odd number of negatives multiplied, we all know, is a negative. And it's easy from here because all signs have to alternate. But man, if that first sign is wrong, then that means that the rest are wrong. So where am I less than or equal to 0 is where the number line is negative. So I can shade in that region. And that's happening from, kind of running out of room here, -infinity to -1, and then from 0 to 1. I won't do this again because it's just not enough room there to put that. Number 9 is kind of an old question. Determine the end behavior of this function. So that means we need to observe x approaching infinity and -infinity. In order to do that, I need to recognize the term, the leading term that is, and that is x to the 6th. Because this is an even power and the leading coefficient is positive, the beginning and the ends are in the same direction and run sure of the behavior in the middle. So that means as x approaches infinity, the f of x's are going off to infinity. And as x is approaching to the -infinity, the f of x is approaching infinity. And number 10, we're going to find the 0 of each function, then determine whether the graph crosses the x-axis or bounces off the x-axis. So here, this 0 is when x equals 0. This is when x equals 1. And this is when x equals -3. At the odd powers, it's going to cross. So that's right here at -3 and 0. And at 1, it's going to bounce off the x-axis or turn and touch. And that should further support why a number line consisting of these zeros, why the number line will alternate signs at -3 and 0. Because when you cross over the x-axis, that's where your y's either go from positive to negative or from positive to negative. They go either way, but they have to alternate signs when the graph crosses the x-axis. But when it's tangent to the x-axis or bouncing off of it, it's strictly where it could be positive on both sides of that critical number, as in this case, or with that critical number, it could be negative to the two sides. And that's why the signs remain the same on that 0 when the multiplicity is even. Like we saw where, back here up at this 4, see how it's positive and positive on the two sides. just like at this -1, how it's negative and negative on the two sides. And number 11, so what's the maximum value? Well, we know the vertex of this is 0, 2. So it's going to be an upside down. I'm not going to graph it because that's not the point. I just need to know the maximum value. And the maximum value will be that y value of 2. So that's the maximum. And the zeros are found, well, set the function equal to 0. I can do that correctly. Keep putting 3 there. So -3 times the absolute value of x equals 0. Just going to subtract the 2 from both sides and then divide those negatives out. And the absolute value of x equals 2/3, but x equals plus or minus 2/3. Okay, and that's a wrap for the solutions for homework number 12.